Calculus! This is AP Calculus Lesson 5-1, Basic Antiderivatives. Today's date is November the 13th, 11/13.
Your hat was going to fall off from that intro?
Yeah, I had to hold on, man. That was crazy.
Yeah.
So today we are going backwards, which is fun. So derivatives is going forwards. Antiderivatives, that's going backwards. So derivatives, let's go ahead and talk about the power rule, right? Power rule, what was the rule? Do you remember? Shout it out. Multiply.
Down.
There it is. Yeah, multiply down. Subtract 1. Okay, so if you're going backwards, then what do I do?
Would it be divide up?
Yeah, so close.
It's dividing, right?
So,
Or is it, subtract or multiply now?
so you have to go this direction first of all. If the last step that we did was subtract 1, we needed to undo the subtracting of 1. So you need to start down here and go this direction. So subtract 1 changes to add 1. Let's write it down.
And that's add 1
To the power, yeah.
Yeah.
To exponent if you want. And then so what we did was we multiplied down. So the 2, if I'm taking the derivative, that came down and got multiplied. To undo that, what am I going to do?
You divide. You divide up.
Yeah.
Like, yeah.
Oh, close. So you definitely divide because opposite of multiply is divide. So let's write that down. Divide. And I guess we can say up or down. It doesn't really matter. But you just know that you're dividing by whatever you added to.
Because it wouldn't seem it wouldn't really seem.
Because it matters because which one is the denominator?
So let's divide down because it's the down number that gets divided by.
But it just seems like as if you're saying 5 divided by 2.
Okay, when we do examples, it'll make sense.
It'll become clear, yes. And here's the key step. We have an additional step whenever we go backwards. In general, though, if you're evaluating, eventually you get to say, okay, between certain numbers, then this doesn't happen. But in general, you always, red star here, add C. And here's the reason. So when we take the derivative of 2, the answer is 0. But when we go backwards, you're like,
You can't divide by 0.
when you go back, well, yeah, so you can't divide by 0. But like, for example, if I took the derivative of 2, it goes to 0. If I go backwards, I say, what's the antiderivative of 0? It's like, it could be 2, it could be -3, it could be 100. It could be any of these constants, any of those constants.
This is going to be like plus K?
So constant, we say C.
Oh.
Yeah. But yeah, you have the right idea. To have all constants, we just say C. So let's go forwards. Let's see if we have this memorized. The derivative of 5x squared is 10x. I know, 4 days without doing calculus. This is what happens.
Wait, 4.
Okay, so it's 10x. Now let's go backwards. So the integral, this is the antiderivative. Let's go ahead and write down its name. This symbol right here we call an integral. Integral. You will be writing lots and lots of these today for homework and on a little bit on the lesson. So get used to it. It's
like a stretched S.
It is because it actually stands for an infinitesimal sum. That's why it's an S. That notation I think was invented by Leibniz, but I would have to double check that. Usually all of our notation in calculus comes from Leibniz, even though Newton was the first one to invent it, but then he hid his work and didn't tell anyone that he invented calculus. Leibniz came along and said, I invented calculus. Newton said, wait a second, pulled the notes out of the drawer and said, I invented it first. It's like, well, great, dude, but why didn't you ever tell anyone? That's kind of not a cool move, man. Discover all these things and don't tell anyone about it. How are we supposed to get smarter as a human race, man? Anyway, so we're going backwards. 10x. So let's add 1 to the exponent. So if I add 1 to the exponent, I now have 10x squared. All right, I did step 1. I need to do step 2. I divide down. And this is the important part. You divide down with your new exponent. My new exponent is 2, so I'm going to divide down. I'm going to divide this 10 by 2. So I'm going to divide, and I'm going to do this in a different color to make it a little bit more clear. I'm going to divide by 2. And when this simplifies, hopefully we get back to our original answer. I also forgot something. What did I forget?
constant?
Yeah, add c. Don't ever forget to add c. So when I simplify this now, this is now going to simplify to 5x squared. Hey, we got backwards, 5x squared, and don't ever forget your constant of integration. And that's technically its name. You don't need to know that, but I'm just going to write it down here for funsies. So this is going to be the constant
So you keep it
of integration. Yes, keep it squared. Once you add up 1, then you're done with the exponent. So C stands for the constant of integration. I will be saying that over and over through the rest of the year, but just know I'm just talking about that capital letter C, that constant of integration. Okay, so we know how to go backwards. It could have been 5x squared plus 1. It could have been 5x squared. We don't know, so we have plus C. Let's go ahead and practice with some harder things. Are there any questions before we move on? Because it's going to get hard, not too fast, but slowly. Okay, I'm taking the antiderivative. I'm taking the integral of -2 times the square root of x. How am I going to do that? First of all, you say, ew, gross, square root of x. You don't know how to do that. We only like powers in this class.
X to the 1/2.
And it's x to the 1/2. So let's go ahead and change it. Let's go ahead and write down the integral of -2x to the 1/2. And we put parentheses around that and put d of x. The reason that we put of d of x, and I should have written it in this example here, this is just kind of being lazy in my notation. Whenever I go backwards, I have to always say backwards with respect to what variable? Because eventually you...
Why does it say x to the -1/2?
Yeah.
It's just the 1/2.
Okay, Rochelle, Ben, give yourself the extra credit point. I don't know what I was writing there. It should just be 1/2. Rochelle, you have your extra credit tracker? Good, all right. It should just be 1/2. I don't know what I'm writing. But that dx, eventually when we look at this graphically, that dx will make more sense. For now, just think about it as going backwards with respect to which variable? We're going backwards with respect to x. All right, so let's go ahead and use that rule that we just discussed up here with the antiderivative. I'm going to do what then?
Add 1 to x.
Add 1 to x. So if I add 1 plus 1/2 as a simplified fraction, that becomes -2x to the 3/2. Because what we're doing here is we're saying 1 plus 1/2 is the same thing as 2/2 plus 1/2, and that's 3/2. So just in case you couldn't follow the 1 plus 1/2, there's 3/2. All right, that's step 1. Step 2.
Wait, what happened to the dx? Is it just
It goes away once you take the antiderivative. So we're taking the antiderivative now. So that goes away, that goes away.
Basically simplifying.
Yeah, you're simplifying the antiderivative. The dx goes away.
Well, if the antiderivative is canceled out by the dx, then why do we have to do the rest of the steps?
So the antiderivative and dx go away once I take the antiderivative. Now that I'm taking it, now they go away. Saying, okay, I'm using them up, I'm going backwards, here we go. Okay, we just did step 1. What is step 2? What am I doing?
Divide down.
Divide down. And what am I going to divide by?
So you're basically multiplying 2 over 3.
Oh, you already see it. Yeah, so we're dividing by 3/2. So dividing by 3/2. And Rochelle saw, oh, dividing by 3/2 is the same thing as multiplying by 2/3. These are equivalent. Dividing by 3/2, multiplying by 2/3. So I'm going to multiply this whole thing by 2/3. All right, and then I need to simplify this. I'll simplify this down here in red. Ooh,
3 over 2.
yeah, I always need my constant of integration. That as soon as we take the antiderivative, have that constant of integration, otherwise you'll forget.
You're multiplying it to 2 over 3. It's,
Negative.
oh, it's never mind.
Okay.
All right. So 2/3 times -2x to the power of 3/2. Can someone simplify that for me? What is that?
It'd be negative 4 over 3.
And then x to the power of 3 over 2.
3 over 2 plus c. There it is. Done. Boink. Box it. All right. Let's try going backwards again.
Wait, what if there wasn't a dx there? Always one or?
There's always one, yeah.
Okay.
If there's not one, then someone is being informal about it. Like if you plug it into Wolfram Alpha or an online calculator,
So it's there anyway, but you just don't notice.
you assume it's there, yeah.
You're basically saying it's a derivative, right?
Hmm.
And if it has a dx, it's basically saying find the what's it called?
With respect
integral?
to x.
The antiderivative.
But
But you have to have both the antiderivative.
Y or something.
So if it was a dy, then you're going backwards with respect to y, and that's a little bit harder. So that's implicit differentiation, but going backwards. So implicit integration, I guess.
But
And
it can be a dy instead of
it could, yes.
Okay.
Are we gonna learn dy?
Do we ever learn that in AB? They won't ever do that to you. They usually just keep it with x. If they do dy, then it will also have a y in there. They won't give you something where it's like negative 2x, negative 2 square root of x dy. They'll be the same. They'll just change all the letters or none of them, yeah. Okay, so let's go backwards. Ugh, gross. Gross. Look at this. How gross is that? Oh, oh gosh.
It's so bad you deleted it.
I deleted it. That's weird. Gross. We don't like fractions in AP Calculus. Fractions are hard. It means quotient rule. Oh, wait. We can get rid of not doing quotient rule. That doesn't make sense. We don't have to do quotient rule because we can change this to what?
3x negative 2.
3x to the negative 2. And don't forget your dx still there. Just be formal about it. If you drop it, you won't lose points on the AP test, but you make Mr. Sindel cry because you're not being formal.
Like when I threw that paper into the recycling. It was when
Did I cry?
You kind of did. You.
Oh, did I tear up? Okay. Don't make Mr. Snell tear up. I don't want to cry in front of you. Okay, so now we're going to take the antiderivative. So we're going to get rid of that integral sign. We're going to get rid of that dx. And I'm going to do what? What's my first step? Add 1. 3x to the power of? Negative 1. Ah, you didn't get tricked on. Usually people fall for that trap. They'll be like, negative 3. No.
Well, I fell for it, so.
Okay. Rochelle didn't. Good job, Rochelle. Didn't fall for the trap. Add 1. And then what? Divide down. Yeah, so I'm going to divide everything by that negative 1. Divide by negative 1. And don't forget your
C.
Your C, or your constant of integration. Let's go ahead and simplify this in our next step. When I simplify this, it becomes
Negative 3x to the negative 1 plus c.
plus c, yeah. And we don't, I mean, you could write this negative 3 over x if you wanted to, but I'm just going to be lazy and say, yeah, you're good. Let's be lazy right there. That's
But
okay.
Don't you hate fractions?
Yeah, we don't like fractions in AP Calculus. If we can avoid it, we'll avoid it. And then combo. Wombo combo. Oh gosh. Gross things in the bottom. And the thing in the bottom is even grosser. It's square root. How are we going to deal with this, class?
Could be negative 1 times x to the negative 1 over half.
There it is. And don't forget our dx. And when I take my integration, when I actually evaluate him, what is he going to turn into? I have my
Be pod
negative x to the what power?
negative 1 over 2.
Careful. Do step 1 for us.
Oh, add 1, so it'd be negative 3 over 2.
Negative 3 over 2. You guys agree?
Why do I? Okay, yeah, got it.
No, it would be positive 1/2.
Wait, is it negative 3 over 2 or is it positive 1?
Oh, it's positive 1 over
Oh, okay, it is, yeah, because if I'm adding 2 over 2, 2 minus 1 is 1 over 2. So yeah, it is just positive 1/2.
half. There you go. Now I fall for the trap.
Got it. And then I fell for it.
That's okay. We're learning from those traps, okay? And then finally, step 2 is to do what? Divide by?
1 over 2.
Yep, and dividing by 1 over 2 is the same thing as multiplying by 2. Yeah, so just multiply this by 2. And don't forget your
C.
C. Your constant of integration. And simplified, this becomes
Negative 2x plus c.
negative 2x to the power of
Um,
1/2 plus c. There it is, done. I mean, we could have simplified that a little bit by, why does it always lags when I draw big shapes unless I go fast, or unless I pause at the corner. Yeah, I could simplify this as negative 2 square root of x plus c, but there it is.
Wait, so we don't simplify it, or will you be mad if we don't simplify it?
We should probably simplify,
Okay.
but I'm not going to be mad at you if you don't. But you should probably do it.
On the AP test,
Yes,
are they gonna, if we don't simplify, do they take out points?
they do not. No. In fact, because we're still in multiple choice, it's not like I'm going to take off points. It's like it's either there or it's not. I just need to make sure on the homework that you guys know how to do it. That's why I usually say make sure you know that that's the same thing as -3 over x, or that's the same thing as -2 squared of x. That's my rationale for making you switch the forms. So you can go back and forth.
On the free response, you shouldn't simplify because it's just another step.
Yeah.
Exactly.
Or- so.
Yep. But in my class for free response, you're going to have to simplify. We won't get that until like, what is it, lesson or unit 6 or 7?
I'm worried about the future. Let's just go on with the terrible present.
Yes, let's go on with the terrible
That's
present.
what we have to do.
So going backwards. If I take the general antiderivative, and this is really key, and this is actually called the fundamental theorem of calculus, it connects these two realms. For a while, calculus was two different realms. It was taking antiderivatives and taking derivatives, although they called it integrals and derivatives. They didn't realize that there was this relationship between going forwards and backwards for a little bit. Eventually, it became clear. It's like, oh wow, you can just go forward and backwards. But this is the key. If I go forwards, if I take the derivative, but then I go backwards by taking the integral, then I'm left with just f of x. Wow, look at that. And then we're always forgetting our plus c, yeah, because we did eventually have an integral, so we do need to have the plus c in there. But that's cool, right? You can go forwards and you can go backwards, and you're left right at the beginning. So what do you think? We're going to eventually do this one at the last step. But if I take the f double prime and I go backwards, I'm left with what?
F prime of x
Yeah, there it is, f prime of x
plus c.
plus c. We're good so far? This doesn't explode our brain? So we need a general way of saying, oh, just take the antiderivative, that evaluates something, and it's the same thing on all AP tests. They use it for their multiple choice questions, never really their free responses because it's more of a multiple choice question. But whenever you go backwards and you just need a symbol, they use the same symbol over and over, and it's kind of weird. I mean, it's the most making sense, I guess, possible. It's just a capital F of x plus c. So whenever you see a capital F of x, you should be thinking, oh, they took the antiderivative. Oh, they took the integral, something like that. It's just the general notation. And it's the same thing in college. It's not like Mr. Sandell's having something cutesy here. This is fundamental, or this is universal in calculus taught around the world. You could say capital F of x in China, they'd be like, oh, you're taking, oh, I don't know how they would say in Chinese. I don't know what accent that was. But they would know that you're taking the antiderivative. This cool thing that math is a universal language. So let's go ahead, and I think we're going to be done after we do this. Yep, there's no back. So let's take the general antiderivative of a polynomial. Oh boy, this is the hardest that we're going to get until we hit the homework, and it's going to be harder than this, of course. So this polynomial, on the outside of the parentheses, there's nothing here. When there's nothing there, it's always assumed to be a power of 1. If you have a power of 2 or 3 or something, this rule won't work. You'll have to first do chain rule, or we call it Dowder and Dinner. You go backwards with Dowder and Dinner, and I'm pretty sure going backwards with Dowder and Dinner, I'll have to double check it, but something special happens or we don't do it. I'm forgetting right now. But because we have a power of 1, let's write this down. Because power of 1, because it's a power of 1, we can distribute the operation, or distribute the antiderivative. And what I mean by that is this integral, that symbol on the left, the integral, this is now applied to the 3x squared, and it's also applied to the 2x because that was a power of 1. If it's a power of 2, other things happen. So that is going to turn into this. We have now this equation. We now have the integral of 3x squared. You always need a dx, so we're going to have 2 dx's now. And that's going to be added to the integral of the other one, 2x. Don't forget your dx. So far, so good? You're just allowed to distribute that integral. Distribute the integration. Okay, let's go ahead and do some more practice with integration. When I take the integral of 3x squared, it becomes... What do I write here?
So you first put 3x to the third,
3x to the third.
and then you divide 3 plus c.
Divide by 3, add on our c, which just means it's x to the third plus c. Yeah, because those two cancel each other out. Perfect. And then we have our plus this side. What's happening on this side?
It would be 2x to the second power.
The second power, yep.
Plus c divided by 2.
Yep, plus c divided by 2. Let's write that all down. Plus c divided by 2, and those 2's are nice. They cancel out. A lot of the time they don't cancel out. I was just being nice for the notes to show you that they do sometimes cancel out. And notice that you have 2 c's here. So when you're adding c plus c, remember the c just stands for all constants, so you only need one of them. You don't have to write plus 2c or anything weird like that. So our final answer here, let's go ahead and write it in. I'm just going to choose red arbitrarily. Our final answer is x cubed plus x squared plus c, box it. Gucci, no questions? Questions? All right, that concludes the notes.